Okay, guys. A model of a car is made to a scale of. Model of car is made to a scale of 1:50. Okay, just means it's 50 times larger in real life. The length of the real car is 4.3 meters. Calculate the length of the model car. Okay, it's length. So what does that mean? 4.3 meters in real life divided by 50. Okay, so that's pretty handy. 4.3 divided by 50, 50 times smaller in real life, and we get 0.086 meters. 0.086 meters. Okay, now please remember that's the same thing as 8.6 centimeters, isn't it? Okay, you multiply to make it bigger. Okay, the volume of the model car. Now this is volume. Okay, now here's the trick. The volume of the model car is 54 centimeters cubed. They want the real car in liters. Volume is how many dimensions? Three. How many times do I need to multiply it by 50 then? Need to multiply by 50 3 times. So 54 multiplied by 50 cubed. 6,750,000. Unfortunately for me, that's in centimeters cubed. How do you turn into liters? Divide by 1,000. And 6,750 liters. Right, that's pretty handy, wasn't it? Question 12 done. Okay, that's 12 done. Now I'm on to 14. Okay, a scoop in the shape of a wedge. A scoop in the shape of a wedge. I think it's basically is it an empty box? That's what they're telling me. I see what they're doing now. From the corners of a rectangular sheet of tin metal from 30 by 20. Show that the volume of the scoop in centimeters cubed can be expressed as this, right? Essentially, guys, the scoop is half a box. It's missing this edge here. Do you get it? And it's also missing the top. Everybody cool with that? Right. Now here's what they're doing. They're basically chopping one edge off. So could anybody tell me the distance from let me see. Can anybody tell me the distance from here to here, not including the x? 30 take away whatever x is, isn't it? Yeah. So that part there is going to be 30 minus x. Okay. Can anybody tell me this length here? 20 minus 2x. No bother. And anybody tell me the height here to here? You're bending it up x. You're folding it up x. So that's where your x is gone. Okay. So essentially what happens there is if you fold this back down again. Let's see if we can do it this way. If you fold that back down again, you add on your x, so it goes back to 30. So you're folding it up. Okay. Now, how do you find the volume? Well, it's a bit stupid the way they presented it, because volume is height by width by length. See the way they have the 2 on the outside? And see the way they have 10 minus x? What do you think I can do with this 20 here? Take out 2, can't I? Now it's exactly the same answer, isn't it? Another option you could do is you could multiply that out, then you could multiply that out, and you could show that they're actually the same thing. Does that make sense? If you didn't see that, you could just multiply them both out and show they're the same. Draw a graph of v against x for values from 0 to 10. Table function, right? And I'm going to need some. What we're going to do here is we're going to multiply. We're going to do our table function mode table. F of x stands for v, so you're going to go 2x bracket 10 minus x. It's been a while since we did one of these. And 30 minus x.
0 to 10.
And then you're going to go from 0 to 10. Step of 1. And you have all these numbers here, yeah? Now this is going to be very difficult to draw. Wants me to draw a quick graph of this, so it's going to be pretty difficult, okay? Because I have to go as low as 0 and as far up as 1250, is it?
Yeah.
Okay, so here's what we're going to try and do. So just take this here. I'm going to need you to call me out some values in a second. So I'm going to make this smaller.
What values did you use?
I'll need the Y value soon enough. Yeah, you'll have more paper to play with than I will, because I had to cut this. So the first thing I do is I'd really extend out the x-axis as far as I could. So maybe I'll just count in trees to begin with. 3, 5, 6, 7, 8, 9, 10. You can see I'm right on the limit there, haven't I? So what I've done there is I've extended the graph horizontally, much better than going up in ones. So it gives me a bit more, it makes it easier to draw and easier to correct, more importantly. Now I have to go from 0 all the way up to what's a 1000? 200. So I'm just going to count my blocks starting off, right? So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I'm thinking 25 would be a good unit. Okay, what's my maximum value again? 1250. 1250. And if I divide that by 25, isn't it? Ah, perfect. Each block can be worth 50, which means every 2 block is worth 100. So 100, 200, 300. You get this, yeah? Now, unfortunately for me, I'm going to be taking rough guesses, estimates as to where some of the points are, because it's just going to be too tight regards space. So, what's the first one? 0, 0. Next one?
1522.
522. So halfway between 500 and 550. Yeah. 3 what?
No, 2896.
Oh, sorry, it's 1.
0, 0, yeah.
Ah, yeah. 2 what?
896.
896. So just above.
Just at the below 900.
Yeah, sort of halfway between the two. The next one?
1134.
Yeah, this does hurt the head. Right, what's next?
1248.
Yeah. That's it.
1250.
Yeah.
1152.
Oh, so it's not symmetrical. 1152.
Yeah.
Down there, yeah.
966.
Yeah.
704.
Yeah.
378.
Going blind. And yeah.
0.
Okay. You'll be doing this better than I will, but generally speaking, I sort of dot the top like that a bit. It works better with pencil. Okay, it's alright. Obviously one continuous stroke. Alright, what's next? Use your graph to estimate the V value when x equals 2.5. So when x equals 2.5, then about 1000. Okay. Next one after that. Value of x when v equals 900. That'd be 2.3 because it's up in trees, so let's say 2.16, something like that. Yeah. 2.2ish. Yeah. Alright. Now, what's the next part then? The maximum value of v and the value of x, which gives you the maximum value. Anybody care to tell me a cheat on this? A mathematical, non-graph way of doing this? As just a bit of revision again.
Find the max in the table. Find the max.
I'm going to go for differentiation. Okay, I'll show you now. So it looks to be a. So let's look at this. So I'm just going to multiply it. If you don't mind, I'm just going to multiply it out. So 60x minus 2x squared. That makes sense? Then I'm going to multiply that by 10 minus x. Once again, I'm just doing a revision where I can. 600x, yeah? Yeah.
Minus 20x squared.
Yeah.
Plus 2x cubed.
Oh yeah, sorry, not 22. Okay. And then all in one go, 600x squared, yeah, minus.
Plus 2x cubed.
You can see why we do this chapter so late, because it has everything in it. You could use differentiation, use trigonometry, you name it. Now, we haven't differentiated yet, so what do we do next? The dx.
600.
600, just drop the x.
160.
Bring the 2 to the front. Reduce the power down to 1. And then 6x. Okay. You'll solve this equal to 0. So 6x squared minus. Why is the derivative equal to 0 again? First derivative is the equivalent of slope, and when your slope is 0, you're at a max or you're at a min. We're going to get two different x values here. Okay. I'll just divide by 2 starting off. 3x squared minus 80x plus 300. I think I would struggle to get the answer here, so I'm going to use the minus b formula. Somebody will just type it into the calculator really quick. That will save us time. So I'm going to do the minus b form. It's going to be 80 plus or minus the square root of minus 80 squared minus 4 times 3 times 300, all divided by 2 times 3. Somebody tells me the 2x values, that'd be great.
What's the square root?
You can do it all. You can just do the plus value first.
Alright.
Then we press the fraction button at the start.
Plus is 22.15.
So x equals 22.15. Yeah, and what's the other one? I think it's the minus we'll be after. 4.514. Now look at this. This 4.514. If we throw that back into the original equation, where's the original equation? Up here, isn't it? And look at the answer it can get. So we know the x value that gives us the maximum amount. So look at this. So it's going to be 60 times, was it? 4.51. Yeah? 60 times 4.51. Take away 2 times
4.51 square.
Oh dear me, did I forget the x here? Oh no, I multiplied in the x already. Never mind. So minus 2 times 4.51 squared. Okay. Close the bracket again. Then 10 take away.
4.51.
Okay. Let's see what our answer is. 1,262.26. Okay. And do you know what the funny thing is? In our graph, okay, in our graph, we actually drew, we drew this as our top, didn't we? But actually, oddly enough, it rose a bit higher. It then dropped down, so there was an inaccuracy in my graph. And if you're wondering about that, let's see if I can get this back up again from earlier on. What was the table again?
2x
2x, yeah.
bracket 30 minus x.
2x bracket 30 minus x, yeah.
Close bracket.
Yeah.
Open bracket 10 minus x.
Open bracket 10 minus x. Now look at this, guys. Remember that trick I showed you about sounding in? So look at this. We did 0 to 10.
Yeah.
And we thought that the maximum occurred at 5, yeah? See the way it drops in between 5 and 6? Now what I'm going to do is I'm going to have a forensic look in between 4, 5 and 6. So look what I'm going to do here. Got to go back a little bit. I'm going to start at 4, end at 6. I'll go from 0.2 just for argument's sake. Look what happens here. See 4.4, 4.6, even bigger. So somewhere in between 4.4 and 4.6, And what was our answer again? 4.51. On the money, what?
Yeah.
Right? And so, and you could almost go back again. Okay? Start at 4, end at 5, go up in 0.1s. Look at what 4.5 gets us in the calculator. It gets us 1,262. And we calculated that earlier as well. So you can rig your answer. If you have time, you can rig it. But in a test, you'd be forgiven for just saying 4.5. That's meant to be the maximum there. And then 1,250 could be your answer, okay? You're not going, remember, calculations is more accurate than graphing, yeah?
Yeah.
Does everybody remember the trigonometric method now? Or sorry, the differentiation method? Okay, so that was the first one I did, was 14. I've also done 12, so 12 and 14. Yeah.